Going to be aiming to build a real-time data and AI pipeline, teach you about some of the moving parts and the different considerations as we go. As always, live demos are always a risk, so I have video backups just in case. A little bit about me. I'm an AI and data platform MVP and run a couple of businesses aiming to help organizations get started with data science and AI. And as much as I love to be able to do machine learning, that usually means my job is actually spent helping people with the infrastructure and the data pieces before they can get to the things that I especially like to play with. I'll be tweeting out the GitHub URL where you can find some of these scripts that I'll be showing today as I go through things. So you can tweet me on the Steph Locke, and we will be endeavoring to do a live demo with live real-time data from this event. So you can definitely start, but we will, I'll put the hashtag Redgate streamed up a little bit later as well to prompt us to start tweeting things so that we can see data coming through our pipeline. So I'm going to be working on building the pipeline. I'm going to first of all kick off some of the resources that are a little slow to build, just because nobody wants to be waiting around whilst a Databricks cluster provisions. And then we'll step by step through partly what has been set up and the different steps in the pipeline. No, I'm just going to share screen. Awesome. So I can show how to build these things from the Azure portal, but I am a huge fan of writing things once and then being able to reuse them again and again. So what I have here is a Azure command line bash script. So behind the scenes, this is on the Windows subsystem Linux 2, and I'm playing a lot with Ubuntu, but this could also be written in standard command line or PowerShell. Fundamentally, this is just the execution of commands against my Azure resource. So we're going to make a resource group called Redgate Stream, and we're going to add a number of things in for our real-time pipeline. So I'm going to start sending some commands to the terminal, and you can see them executing at the bottom. So we can make a resource group. And this is called Redgate Stream. So that has successfully created. We're then going to make a number of other things that are necessary for our real-time pipeline. And the great thing is, once you've written this code, it might take you a little bit longer than 60 minutes to be writing it as code, but then you get free time again and again. So we can send commands like creating our storage account. We can create a cognitive services account. I maybe shouldn't queue them up quite so aggressively. Cognitive services is the Microsoft off-the-shelf AI solutions that enables us to perform things like working out what's in images, what is the sentiment of what people are saying. Still typically not quite good enough to get sarcasm, but we're working on it. We'll then be making event hubs. Event hubs we'll see inside the signal and listener are a great way for us to be able to work with a scalable and distributed data platform in the cloud. So we've made our cognitive services. We're going to make our event hubs. And these are all relatively quick to create because there's no virtual machines, which means that you can build an infrastructure really quickly if you're using the platform as a service component rather than infrastructure as a service. Infrastructure as a service being primarily virtual machine-based solutions that you might also have to take care of things like patching of. I personally never want to patch anything if I can help it. Okay, whilst that's working, stop sharing. You'll see my dogs in the background. Dobby just went outside and rolled in all the mud, so he's had a shower, and that's why he's in a very fetching blue towel cape. Okay, so many of you as data professionals may have already have this understanding about the different stages in a data pipeline, going from some source to a destination and then having some reporting. But when we work in a real-time setting, instead of having a batch triggered like a once-a-day situation, we need a signal to let us know that something is going to happen. So a signal inside commonly a real-time setting like we're doing today will often be a queue of some sort or a message hub. So two common ones that you can use in Azure are event hubs, which is just a generic queuing capability, or IoT hub, which also enables you to communicate back to the devices that are sending signals. So you would use event hubs inside your application infrastructure. You would use IoT hubs to communicate externally to things that might be sending things to your application. That gives you the ability to like block fraudulent devices and things like that. So you need some signal. We're also going to see, actually, I'm going to be a little bit sneaky today, and we're going to use Twitter as a signal and dump it into our event hub to mimic some application that you might have. You then need something that listens out to the trigger. So this should regularly be either kicked off by the signal happening or be regularly checking for whether the signal has been whether the bat signal has been turned on. So some common types of listeners that we have in Azure. We have Azure Functions. Those can be written in a variety of languages, C# and JavaScript being the most prevalent. You can listen out to things like event hubs, new blob files, and other changes. You can also call it on demand. The same is true of Azure Logic Apps. So we're going to use that today because it is a great no-code, low-code capability with a bunch of pre-built triggers and actions that mean that we spend less time coding and getting more time to the value, which is getting our data in our hands. It is also quite handy because Logic Apps and Power Automate in the Power Platform stack can be interchangeable. So if you make a Logic app, you can export it and import it into the Power Platform and vice versa. This means that business people can be creating listeners to listen out to important signals to them, and you can integrate that into your production pipelines. Two other key listeners that you might use is stream analytics, which enables you to listen out and aggregate and route data as it comes in with sophisticated time and geographical capabilities, and Azure Databricks. Azure Databricks we'll be using in a number of settings, but it has the ability to perform listener capabilities. That means with Azure Databricks that you will always have a small cluster of virtual machines running to perform the listening action. So you have at least some dedicated cost happening even when signals are not being emitted. So the Azure Functions and Logic apps are pay-per-execution. So it scales to your signal volume, but your Databricks gives you a firmer, more reliable view of your costs. We can then supplement the data as it is coming in. You can also do insight once you've stored it, but then you can't you can't process the data that has come in and use insight immediately if you perform batch situations. So if we can perform insight as we're listening to the data to do things like sentiment analysis, fraud detection, anomaly detection, and other things, we can be more rapidly responding to whatever event happened that emitted the signal. And the quicker we can perform the relevant action, the more money we save, or the more money we earn, or the more reliable and better quality our service is. So being real-time and real-time with our insight enables us to add a lot of business value. One of the key ways that we'll be doing this today is with Azure Cognitive Services. That is Microsoft's off-the-shelf and, in some cases, customizable APIs. So this is great if you don't have any data scientists or AI engineers inside your organization right now. You can rely heavily on the work that Microsoft and particularly Microsoft Research Cambridge have done to build amazing, good quality solutions. There's Azure Machine Learning and Azure Machine Learning Studio, which is now technically deprecated, but you can build your own models and make them available in Azure, typically via a Docker container, but that ends up creating an API as well. We can use Azure Databricks. Azure Databricks has the ability to run R, Scala, Java, Python, and SQL. So it has a wide range of languages that we can be using to process and add insight to our data. We can also use HD Insight, which is a Hadoop-based open source distribution that Microsoft have that enables you to not just run the Spark types of queries that can be run in Databricks, but also a broader range of capabilities. You can add in really anything at this point that has an API. So it doesn't have to be something that is in the Microsoft stack. You can go out and call algorithmic marketplaces like Algorithmia to be able to supplement your data with insights. It can be as simple as going and getting a weather forecast to see if the engineer field booking that's just happened is going to be taking place during a storm. And, sending an alert to say, hey, you might want to take your jacket when you go to this event, go to this visit. Then you can store your data. So you can store your data in any way, really. There are tons of options. You can store it in the Azure SQL database, the MySQL, MariaDB. I've forgotten the other one. We have lots of database variants. We can also store it in Cosmos DB as JSON, or a time series value, or a relationship node inside Gremlin API. Lots of options there that can suit the type of data that you're processing. You can load it into table storage, which is good and optimized for when you want to be able to bring back specific records. SQL Data Warehouse, now called Synapse Analytics, is also an option for storing large volumes of data. And you can also store data inside Databricks with the Databricks file system, or bring it into Azure Data Lake and feed that data into Databricks. And then finally, once you have that data and you've supplemented it, you might have routed it to various places, you commonly need to visualize the data. So we can do that inside Databricks, we can do it inside Power BI, and we can use Azure Data Explorer for particularly high volume types of scenarios. So you've seen Databricks quite often along this chain of process. Depending on the skill sets in your company and various cost appetites and volume considerations, you could use Databricks as an all-in-one solution. It's one of those typical things that if you heavily consolidate, you can leverage any dedicated resources more effectively, whereas if you have a low volume sort of situation, a more distributed system might end up more cost effective. So we're going to be building our signal listener, performing insights, storing our data, and visualizing it today. So that's a whistle-stop tour of your real-time options inside Azure. Okay, so we're going to go back to some more demo. Now I'm going to share my entire screen so that we can check out what's being built here. Okay, so far I've deployed a cognitive services resource for our insight, for part of our insight, our Databricks service, which can act as a listener, our event hubs for getting data, and a storage account for being able to store images and things like that. So next up, I'm going to work on these bits and pieces, do some magic infrastructure access control, so we get authorization to be able to perform capabilities inside our Databricks cluster. This is great for being able to get things set up without needing to manually do it. So this is just getting some information to be able to process things like this URL. And then we can get a token for acting in our Databricks cluster, Databricks workspace. We can add some configuration. This enables us to continue working at a kind of device level and non-interactive level. So we've installed the Databricks CLI and added our key information like our URL into some configuration. And we can now do some things like creating a cluster. So whilst that's creating, let's go into our Databricks and make sure we can see this all setting up. So Databricks gives us a portal which we can use to create our analytics and monitor what's happening. So once we've configured our signal and our listener, we'll be using Databricks to process things, to add our insight and store our data. And we can make sure that it is working by querying that we have a cluster ID. That is still waiting. So already my script that worked just a little bit ago I cleared down my Azure environment, but did not clear down my local environment. So here I'm just getting the results of creation steps. And this is saying my authentication may be incorrect. So my PAT token is currently empty, which is the problem. Okay. Or we can do this manually, not a problem. So we can generate an access token. This enables us to work interactively with our machine in Azure. I can cheat a little bit. I'm going to remove my config. Rerun that. And now, hopefully, my cluster will create. Whilst that's creating, let's get our signal set up. So what we need is a way to listen out for tweets to come in and for those to be able to go to our event hub. So we're going to use a logic app to listen out to tweets, process them so that we don't bother with retweets and cause excess work, and write them into our event hub. So I'm currently deploying a logic app. Here's one I wrote earlier. If you haven't used ARM templates before, these are a JSON representation of resources that you can create in Azure. So that's gone through, and now I have my connections and my logic app. So we're going to connect to Twitter. I need to give it my authentication details. And I've got multi-factor authentication, so we will hopefully get that shortly. So our hashtag for today is Redgate stream, and we will check every 30 seconds. We're going to make sure that it's not a retweet. We're going to connect to our event hubs. And I need to quickly change that name. We're going to go through and send a tweet, JSON, that has come through to our event hub. And then for every URL, we're going to go and get the file, and we can write it to blob storage. This will go through and validate, so our tweets will now listen out. We'll now listen out for tweets. We'll dump them to event hubs and write files to blob storage. So it will check every 30 seconds, but if folks start tweeting now, we should be able to see the data come in. And why did we get an error today? My partition key was wrong. So I'm now falling back on the older version of the task. Preview one is playing up. There we go. So we have some new tweets. Redgate streamed. Hey, Kendra. And we can see it's gone through. It didn't have any images, so it didn't create any blobs, and it has sent the event. Okay. Phew, we have our listener and our signal. So the next thing we need to do is install our little bits and pieces on our cluster. That will enable us to work with event hubs. And you can also, if I'm not going to do it today, you can also use the MML Spark package to write data to the real-time tile view in Power BI. So we need some stuff inside Databricks. So we can import some notebooks. Here's some I wrote earlier. And now we're going to build our listener. So this is going to listen out for things written to the event hub and start processing them in a stream. So I need a couple of things. First of all, I need some connection details. So I'm going to go to my event hub. And grab a connection string. I can paste that in and get my hub name. So this will now run on the cluster of virtual machines that have Spark and Event Hubs capabilities installed. If I finished off my install correctly. Okay, why did this error? Cannot initialize. Couldn't find event hubs. Class definition. Okay, now that one, I'm not sure why that one's happening, but as I said, we have a video. Always bring a video. Okay, so we correct our connection. We make our connection string and update our event hub. What this is going to do is start sending our stream to something called a delta lake. A delta lake is a semi-real-time data lake. So it's storing the data in a really scalable platform, but it will be appending data as it comes in. This enables us to set up the schema and be able to run things more effectively. This gives us also a permanent record that we can use as our cold path for alternative analysis. Once we're processing that data, we then need to be able to supplement it with our AI. So we're using cognitive services for that. So we went and got the key. So now that the data is streaming in to our Delta Lake Twitter table, we can go and start our supplementation processes. So we're just going to do the do the one for images, and then switch to the one that works for text. So if you remember, we were writing the images to blob storage. So we can now read that data in lots of different notebooks or solutions because it's in the Delta Lake. So this is a really important thing when you're building distributed data pipelines, is you want to build things that can have multiple connections to the data that don't lock each other out. That gives you the ability to really scale the service and have multiple processes running off of things. So let's take a pause there and quickly check out some of this code in a little bit more depth for you. So we have an incoming stream. This is our listener for our event hub. We can then transform that data, which is usually what we want to be able to do because data really comes in the perfect format. and we start writing it to a Delta Lake table. We can then consume that by reading that table. And the MML Spark library brings in a number of cognitive services wrappers that enable us to build our insight process. So we can use a language detector to work out what language people are tweeting in. We identify the column that we want to analyze. We say, we give it our endpoint and our key, and we add the column language as our output. I said earlier we can use a multitude of languages in Databricks, one of those being SQL. So we can transform our records using SQL, which helps us keep things in a more tabular format that many of us are more comfortable with. And we can perform sentiment analysis and similarly supplement our sentiment analysis records to our data. We build a pipeline. So we're going to go through a set of stages. We're going to run language against our data to find out what language it is, add that detected language to the data, then perform sentiment analysis on it and add the sentiment score to our records. And then I'm going to sync that data into another Delta Lake. So we're going through sets of stages where our data is becoming increasingly more valuable as we're refining it, but giving us multiple stages with which we could branch our data pipeline into more of a data network. So once we get the streams up and running, these will now be listening out for new files in the blob storage or new events in our event hub. I even make my here's one I made earlier realistic by putting errors. We have an extra E in it. So I'm just opening up the other notebooks. You'll have these on GitHub, and I'm going to be pushing today the updated build pipeline script because that has the Active Directory tokens, which is a relatively new thing. So I've opted to do a lot of this inside Databricks because this, in the real setting, you might not just be using cognitive services, you might be using custom built models, doing database lookups, and a lot of different complicated pieces that having a programming language can really assist you in doing. So it's going through, it's getting the tweets now, and we can go and we can start visualizing that data. And we can even have dashboards that as the data is being processed, we can be getting the sentiment of it and watching it update in real time how things are changing. So we can see more tweets coming in. What we can also do with this is if your data pipeline is something that you're a bit less comfortable coding with, you can actually do a lot of this inside your listener because logic apps and function apps have a lot of capabilities that we can leverage around Microsoft's off-the-shelf AI capabilities. So you can take information from your cognitive service and consume it actually directly inside your logic app. So we just had a wee issue with containers. So we can watch this rerun, hopefully now that it's fixed. Now I have to use one of my favorite GIFs. Awesome. Frustratingly, sentiment is not always perfect. I think favorite GIFs should be a little bit higher, but we now have a sentiment score and we can be routing things based on that sentiment. So we can be supplementing our data inside no-code solutions or low-code solutions like Logic Apps, as well as taking it to a more next level, in-depth, more sophisticated solution where you can bring in a variety of techniques that might involve off-the-shelf solutions, custom-built models, and third-party APIs. So we've gone through, we have generated our signal, processed it in event hubs, used Logic Apps to get that data in. We can also use functions and event grids for the image processing. We've seen how we can use Databricks for insights into to add in artificial intelligence results relating to our data. We can store that data either in blobs, event hubs, but we've also been persisting it to the Delta Lake tables, which is a long-term storage solution for providing data that we could use in batch processes as well. And you can go and visualize the data either in Power BI or in Databricks. Databricks has the real-time dashboarding capabilities as well. So thank you everyone who tweeted to get the data. MML Spark, which is the bit that wraps the API pieces from cognitive services and supports the writing to Power BI. One person in particular has been a major developer of that, Mark Hamilton, now I think still works for Microsoft. So there's a lot of pieces in here that are actually open source, and that means that we're able to mod them if and when we need to. So thank you very much. I will tweet the GitHub repo and be posting some of the snazzy authentication changes that I've made a little bit as soon as I get off the talk. I will be around for questions. Thank you all very much for coming along today. Hopefully you now understand what a kind of a real-time data and AI pipeline might look like, and some of the different technologies you could use to meet your situation's needs. Thank you all very much.
Thank you, Steph. That was awesome. So I knew almost nothing about this before you started, so I have learned a ton. And I noticed that for folks who do download the slides, it looks like you added some additional reference slides for learning for people in the slide deck to help them familiarize, which I really appreciate that. That is super helpful, and I will make use of those. So for folks who do download the slides, you can dig in to those as a reference, which I think is just super valuable.